So what's been causing this period of heat for us is what is called an omega blocking pattern in the upper levels of the atmosphere. So if we take a look right here, what an omega block looks like, it resembles kind of the capital letter omega. If you're unfamiliar with that, also kind of resembles a horseshoe type shape. So if you can, just kind of using kind of an abstract thought here, this is kind of where the center of the omega is, or the center, and then it's flanked by two relatively lower pressure systems. So what this can do, depending on the strength of this high pressure that's in the center, if it is strong enough, it will actually block or prevent a pattern change coming into the area. So these low pressure systems, rather than being able to push the high pressure out of the way, it'll take the path of least resistance and will opt to go around the high pressure system. So what high pressure at the upper levels of the atmosphere, what it produces is a relatively lower pressure system at the surface. So if we kind of zoom in here, where these very dark maroon and red colors, this is kind of over the Great Basin, kind of getting into the Four Corners area. What we are having is what is called subsidence or compressional heating. So imagine, if you will, you have the air in the atmosphere just getting pressed down harder and harder and harder, all right, into a smaller and smaller container, essentially. So when you do that, the molecules start moving faster and faster and faster and warming up. And that's what we are seeing here, is that we're seeing molecules from the upper levels of the atmosphere, as they move down towards the surface, start warming up, which is what they do anyway. And so when you just try and compress a volume, either like a volume of liquid or a volume of a gas or whatnot, into a smaller and smaller area, it gets warmer and warmer. All right, and that's basically what's happening here, is that things are starting to get warmer and warmer and warmer, and so it impacts us here at the surface, where we have multiple days of 90 plus temperatures and even 100 plus temperatures. And that's pretty much what we are experiencing right now. On the plus side, we are looking at a pattern change in the area starting kind of late tonight going into tomorrow, where if we zoom back out here, this low pressure system right here, so just to give you an idea, this area right here is kind of the western end of Canada. So this low pressure system and its surface component is moving eastward. And what it's going to be able to do, it's going to be able to kind of flatten out this high pressure and kind of start pushing it and deforming it and getting it moving to the east. So that's going to allow relatively cooler temperatures to start impacting the region. Now, by relatively cooler, I mean we're talking temperatures in the upper 80s, lower 90s, which is, relatively cooler than 100, 105. At least I hope so in my mind. That's how that works. So yeah, that's going to be kind of the next major system coming through. And that will, at least at this particular moment in the forecast, bring us to more kind of seasonal norms for this time of year. So in July, I know it seems a little counterintuitive, but seasonal norms for up here, daytime highs, typically run in the upper 80s to low to mid 90s. And so this will kind of get us into a little bit more of a seasonal temperature pattern, at least through the latter part of this week and hopefully continuing into the weekend. So when we are talking about long-range forecasts, typically 1 to 3 months into the future, we go to the Climate Prediction Center. Now, the Climate Prediction Center, one thing that you have to remember is that we're talking trends. We're not talking hard numbers or anything like that. We're just talking trends in comparison to what normal is. So if we take a look here at kind of the 3-month outlook, we can see, so we're over here in the Pacific Northwest. So for July, August, and September, there are equal chances of temperatures being near normal, above normal, or below normal. Now you're going to ask me, well, what the heck does that mean, right? So equal chances are, is that when you have three options, you have a 33% probability of temperatures being above, 33 for being normal, 33 for being below. Now, depending on where you go in the country, those values can change. So obviously, if we're, say, over in the Four Corners region, the Climate Prediction Center is putting at about a 70 to 80% probability of being above normal, which will likely translate and shake itself out to maybe about 20% near normal and maybe about 10% or so probability for being below normal. Rough math here, rough math. And then if we take a look at precipitation, again, it's the same idea where we're at about an equal chance of either being above normal precip, near normal precip, or below normal precip. So long story short, what we are seeing for the next 3 months, for July, August, and September, for at least Oregon and a good portion of the Pacific Northwest, no real clear signals as to how temperature and precip are going to shake themselves out. So hopefully that at least explains that a little bit more.